LTX Video is a newly open-sourced, highly popular video generation model. It can generate fairly good quality outputs at lightning speed, and even supports small 6GB graphics cards. However, some of you might be thinking, this is too good to be true. Why are my videos either not moving or crashing badly? This is because, although LTX Video has no resource limitations, there are many important details to consider when using it. In this video, I will explain and demonstrate LTX Video's various features in detail, including text-to-video, image-to-video, and video-to-video with style transfer, so you can avoid common pitfalls. The most comfortable way to use LTX Video is through Comfy UI, which also supports it right away. The video highlights three key features of LTX Video. Real-time image generation speed. To generate a 5-second video with a resolution of 768 by 512 and a frame rate of 25 fps, it takes only 4 seconds. High video quality, providing smooth motion and excellent consistency. Easy to use, Comfy UI natively adds nodes that supports LTX Video. And you can also use the official custom node LTX Video from model provider. Below are two basic workflows. One for the native version and the other for the plugin version. We'll take a look at them during the demonstration. Now, go ahead and download the model. The open-sourced model includes a VAE with a total size of only 9.37 GB, which is more user-friendly compared to Flux and SD 3.5, which are over 20 GB. However, if you're using an 8 GB or even 6 GB graphics card, you can choose the GGUF version model in different formats. However, the GGUF version does not include VAE, so you will need to download a separate VAE file. There are two options for clip. The one recommended natively by Comfy UI is T5_XXL, which is the same as Flux and SD 3.5. The 9.1 GB FP16 version and the 4.5 GB FP8 version are not much different, and it should be placed in the model/clip directory. The clip used by LTX Video nodes is PixArt XL 2-1024 ms, which is around 20 GB and can be cloned into the model/text_encoders folder via GitLFs. However, it's quite large, so I prefer to use T5_XXL. The first thing you need to do when opening Comfy UI is to install the plugins. Search for LTX, without the V, in the manager, and you'll see two plugins. Comfy UI LTX Video is the official one, but since Comfy UI's native support is already pretty good, it's optional to install. Comfy UI LTX Tricks doesn't require any dependencies and provides video enhancement STG and various video-to-painting methods. It is highly recommended to install this. In the workflows I will demonstrate and share, I also used several plugins that have simple dependencies, so feel free to install them. Remember to restart Comfy UI once you're done installing. Let's start with text-to-video generation. Load the text-to-video workflow provided by Comfy UI, and run it without making any changes. It will generate a 97-frame video with a resolution of 768 by 512 and a frame rate of 24 fps, which plays for 4 seconds. After waiting for a while, you may not feel the lightning-fast speed. This is because both the model and the clip need to load for the first time. The video successfully generated, and the sampling time shows 12 seconds. While the promotional claims might be a bit exaggerated, the speed is indeed impressive, far surpassing models like Cogvideo, Mochi, and Pyramid, and even faster than Anime Diff LCM from the SD 1.5 era. There are a few parameters to pay attention to. The width and height of the resolution should be multiples of 32, and landscape videos work better. It's best not to exceed 720 by 1280, the number of image frames should be a multiple of 8 plus 1. The steps should be between 20 and 30, but going up to 40 can improve quality. The sampling methods support Euler, Hune, Hump2, DPM_2, Ds, DIM, etc., but the results are generally similar. Some users might encounter the issue of generating a completely black video. This is typically due to OOM out of memory during VAE decode. You can solve this by switching to the VAE decode tiled node, which won't affect the generation quality. Just replace the node connection and run it again. And this time, the result is good. The default workflow saves in WEP format. Let's change it to Video Combine. Set the FPS to 24, and change the format to MP4, which will generate a higher quality video. Click Run, and how does it look? The MP4 format indeed produces better results. As mentioned earlier, LTX Video also has GGUF format models. After downloading, place them in the UNET directory, and you will need to download a separate VAE file and place it in the V directory. To load the model, change the node to UNET Loader, GGUF, and load VAE, keeping the other settings unchanged. I'm using an old GTX 1066GB GPU with 16GB of system memory and the Q8_0 model. I successfully ran it with the VAE decode, tiled, node, although it was a little slow. So, even with an average GPU, it still works fine. LTX Video has high requirements for the prompt. Many users fail because their prompts are not formatted correctly. I'll use a simple prompt, a cute woman, and fix the seed for easier comparison of different parameters. Click Run. And the result is terrible, it doesn't even look like a complete human. Following the official suggestion, I expand the prompt. Click Run. And sure enough, it works fine. Now, the result is a young woman sitting on a wooden bench in a park, smiling and looking forward in the bright sunshine. If you find writing prompts troublesome, you can let a large language model generate the perfect prompts for you. However, the video still has some issues with detail, and it looks a bit blurry. We can greatly improve this by adding STG. According to the official example, it can be combined with Mochi, SVD, OpenSora, etc., and can improve sample quality without sacrificing diversity and dynamism. Now, let's add STG to this workflow. Add the Modify LTX Model node. Connect the model, then add an LTX Apply Perturb Detention node. And connect it with an LTX Attention Override. Set it to 14, which currently produces the best result. 8 is also fine. You can experiment with other values. Update the parameters, and reduce the scale and rescale values to 1 and 0.25, respectively. Copy the sampler custom and VAE decode nodes. Connect the modified model. And add an image concatenate node, which can merge two video results for easier comparison. Connect both sampler results to the image concatenate node and then to the video combine node. Click Run. STG will make the sampling time slightly longer, but the node processing time is only 18 seconds, so it's not a big deal. Now, let's check the results. On the left, we have the version with STG applied. It's much clearer, with the character's facial features complete and flawless, and the motion is natural and smooth. Now, let's move on to image-to-video generation. Relying solely on prompts to generate video can result in a lot of randomness, but by using ControlNet and IP adapter to define the first frame image, it's easier to generate videos that meet specific requirements. Before we begin, let's detach the model cached earlier because the model was modified with STG, and it will conflict with the native image-to-video node. The image-to-video workflow provided by Comfy UI is quite simple as well. Load an image. Add a resize image node to adjust the image size to 768 by 512. Complete the connections. And then focus on the prompt. There are two key points here: 1. Be as detailed as possible, and 2. Describe the image content along with the desired action. I'll write a short description: a small robot walking in the garden. Also, fix the seed to make it easier to compare with the optimization process later, and save it as a 24 fps MP4 format. Click Run. After waiting for a few seconds, the sampling completes, and the cute little robot starts moving. But upon closer inspection, the head is deformed, and there's room for improvement. There are several methods we can use to enhance the quality, so let's apply them one by one. First, here's a suggestion from the LTX video developers. Since the training data used image frames from video appearances, the model performs better with this kind of input, preventing freezing and low-quality cutout effects. We can fine-tune the images with an H.264 encoder. Add a video combine node. Set the FPS to 1, format to H.264 MP4, and set CRF to 23. Then, add select file name and load video, path, nodes. Connecting the former's output to the latter's input. This cleverly converts the image into a video and brings it back. Then, connect the processed image to the LTX video image-to-video node. Once this is done, click Run and wait for the result. Since there was no freezing or other issues in the previous run, it didn't show much improvement in this case. But I suggest you add it, as it might come in handy at some point. In the earlier text-to-video process, STG performed well. Can it help optimize this video? Add the Modify LTX model, LTX Apply, and LTX Attention override nodes. Keep the parameters the same as before. However, there are a few differences in the subsequent steps. Besides copying the sampler custom and VAE decode nodes, we also need to add a few other nodes. Start by adding the empty LTX video node to provide latent. Note that the width and height and the length, number of frames, here define video parameters, and batch size should be 1. Then, add the Add LTX Latent Guide node. Connect the generated latent and modified model. And link the image_latent to the VAE encode image. Complete the remaining connections. Also, add an image concatenate node to compare the results. Click Run. And as expected, STG works wonders. The generated video has smoother, more natural movements, and the robot's head is intact and undistorted. So cute. However, as I mentioned before, modified models can conflict with the native Comfy UI image-to-video node. You can either force uninstall, or only use the workflow with STG-loaded nodes. The image of the small robot I input earlier was actually generated by the Flux text-to-image workflow. Can we combine it with the LTX video image-to-video process and generate high-quality videos with just a simple prompt? No problem. Load a workflow I've created, which is based on the design shared by Avatar AIM. It's mainly divided into 4 parts. Flux text-to-image, extract detailed prompts, image adjustments, and image-to-video conversion. At the top is the standard Flux text-to-image workflow. Input the image, video, subject and let Flux do its thing. Be sure to select your local Flux model, or else a mismatch in file names may cause errors. I've written a simple prompt. A robot wearing a daisy dress walking in a flower field. The image generated here will be passed to the Florence 2 workflow below, which will describe the image in more detailed caption. From testing, Many large language models, including Joy_Caption, can do this, but Florence 2 works best with LTX video. Next, we use the H.264 encoder to process the generated image, and then input it into the image-to-video workflow. The node parameters are the same as what we've explained earlier, including the STG part. Just click Run to speed it up. The result is out. Hehe, can you tell? It's the same cute robot I just showed, with different movements this time, but still adorable. By using this workflow, you can easily turn a simple prompt into a video, streamlining the process. In addition to the basic text-to-video and image-to-video, the Comfy UI LTXtricks plugin also provides a series of more complex applications, such as video editing with RF inversion or RF edit. The effects look great. Generally speaking, inversion is more suitable for large changes, though it may produce dramatic effects, while edit is better for small adjustments, offering more control. Personally, I lean towards using edit. I won't go into detail on these two, as I'll share the workflows with everyone. Next, I'll demonstrate the image-video-to-video functionality. Simply put, it generates a new video that references both the first frame and the video's actions, making it perfect for style transfer. I've chosen a scene from Titanic, where I plan to transform the female lead into an anime style. First, I load a Flux style transfer workflow. I plan to extract the 211th frame for redrawing. So, I set the video to skip the first 210 frames and take frame 211. After passing through the Flux image-to-image process, the redrawing intensity is set to about 0.8. I continue using Florence 2 and add a string function node, placing the style prompt anime style in front. Click Run. This preview shows the frame I want to redraw. After running it, the result is pretty good, quite faithful to the original, with the red hair and pearl necklace intact. Now that the preparation is done, I load the image-video-to-video workflow I've organized based on the plugin examples. This workflow is quite long and complex, but fortunately, we don't need to adjust many parameters during use. The process has 5 parts. The input part is very simple, just the model and video. I load 33 frames starting from frame 211. The second step is resampling, which those familiar with RF inversion will recognize. The recommended parameters are like this, and it also stores the attention here. Next is image injection. Here, we upload the redrawn image and replace it. In the previous style transfer workflow, I copied the result I just generated and pasted it here, though you can also directly load a prepared image. Then comes the attention injection, where we inject the blocks stored in the bank. This ensures the model captures some style information, while adhering strictly to the actions from the input video. The final step is sampling. I just fill in the prompt from the image I just generated, since the video serves as the guide. We only need to focus on describing the image, without needing to specify actions of the character. Click Run. This workflow is quite complex, because the plugin exposes many internal parameters for us to adjust. But don't worry, you can use the default values of the workflow. For example, here I only selected the model and image and filled in the prompt. The result is out. The video follows the actions of the original video, while adhering to the style transfer we applied, creating an anime style version. I then join the newly generated video with the first part. I add an image batch multi-node, which can merge 2 sets of video frames. The style transferred result forms the latter part of the original video, which I connect to image_2. Then, I add a load video node to load the first 210 frames of the original video. Resize them to match the dimensions of the generated video with a resize image node. And feed them into the image batch multi-node as image_1, front. Finally, I use a video combine node to merge everything. Click Run. And the result is ready. Let's take a look. Isn't it fascinating? It switches from a real-life scene to animation in just 1 second. That's it for the demo part. I believe you now have a pretty good understanding of the various ways you can use LTX Video. To summarize, LTX Video is a super fast image generation model that can easily run on consumer-grade GPUs. It excels at text-to-video, image-to-video, and video-based style transfer that uses the first-frame image, but to generate good videos, you need to pay attention to the details. As for the future of LTX Video, the developers have revealed that they will train it with more high-quality data, fine-tune its aesthetics, and release a 1.0 version under an open license, free for commercial use. I look forward to the day when the model is open-sourced. Well, that's it for today's video. All the models, plugins, and workflows mentioned in the video can be found in the description below. See you next time.